Welcome to College of Technology Chemistry 2016. Now we will discuss about Q2. Q2 says, which is the polar molecule among the following molecules? Okay, we have hydrogen, chlorine, carbon dioxide, water, and methane. Okay, now polar means that, polar molecule is that when you have a compound, there is one element has drastic difference of electronegativity with other element. What it means is, let's say we have water here. You see that oxygen is placed in the 6A, right? And H is placed on 1A in the periodic table. And you see that the trend that is in electronegativity, when you go from right to left, the electronegativity will get higher, right? And when you go from right to left, the electronegativity will get smaller. So with that big difference of space, it means that oxygen have higher electronegativity than hydrogen. It goes drastic difference. So I got here a periodic table of elements, the electronegativity. You see that H has the electronegativity of 2.2, right? You can see that. And H is much distance from oxygen. You see oxygen here in the red, it says 3.44. So that is the drastic difference of electronegativity. So we must identify this one, which has the most electronegativity. The drastic difference. If they have drastic difference, means they are polar molecules. Okay, so the one who is usually is polar molecule is when they have a hydrogen bonding, but the hydrogen must be bound to these elements, H2N or H2O or H2F. This one must be polar molecule and they are called hydrogen bonding. If you got like option 1, that is H2H, this is diatomic molecule. This is not polar, this is actually non-polar, right? Because there is no difference between the electronegativity of H and H. Same as it is as chlorine. Although this element is very high in electronegativity, it has 3.16 actually. You see 3.16, right? But because they are both two bonded together, they didn't have any difference in electronegativity. Therefore, it is non-polar. And for option 3, you have CO2. Okay, you see that in this table, C has 2.55, right? And oxygen has 3.44. You might think that this is actually a polar molecule. Yes, but the big difference is it has 2O, right? So this has 2.55 and it's 3.44. When this carbon has the drastic difference with this oxygen, it also has the same difference with this second oxygen molecule. So we can say that this is actually balanced, right? It has balanced difference. The drastic difference is balanced from the exact same drastic difference. So therefore, this is also called non-polar. While number 4 is actually H2O. Now you see that H has 2.2 and oxygen has 3.44 and 2.2. You can see that the difference between this and this is that oxygen is trying to pull carbon and this oxygen is trying to pull this carbon. Okay, so they are balanced, so no one pushing each other, right? While this one, oxygen with higher electronegativity, try to pull H, and this H is also get pulled. So this hydrogen is both get pulled to here, right? So by means of this is actually a polar, because no element that wants to pull H from the other side. Both H are both pulled by this oxygen, while this CO2 is pulled by that and it's pulled by that oxygen. So they are balanced. And of course for number 5, CH4, you see that it is actually not a polar molecule. This is actually non-polar. Okay, and you see that from these requirements that H must bond to N or O or F. You see that the answer is number 4, because H have the hydrogen bonding with oxygen. If H is bond into carbon, it is not a polar molecule, same as the diatomic molecule. Okay, so that is for Q2.